All right. First, let me introduce myself. My name is Marc Schoolderman, or Schoolderman. I like that pronunciation, so thank you. And I want to talk about something that, as a relatively newcomer to the Rust programming language, but not as a newcomer to programming languages in general, was the first thing that I noticed in a Rust project, and that was dependencies. So let me first tell a little bit about my company background. So I come from a company called Tweede Golf in the Netherlands, but if you pronounce it like Tweede Golf, that's perfect. And our motto as a company is software must become safer. And what we mean by that is we want software to have fewer vulnerabilities. We want the internet to become more reliable. And we also want to help build a next-generation digital infrastructure that is more resilient and more reliable. And what we firmly believe at Tweede Golf is that the way to do this is by using open source and Rust. So let me talk a little bit about this slide, because this slide is basically the short version of my presentation. So what you see here is, of course, Ferrous the crab. You probably know him if you're here. And then there's this word cloud that I found on the internet that represents open source for me. And of course, some of you in the audience might already have noticed that open and source are in the wrong order here. But one thing that I also noticed and that I really liked here is that the word library is very large and it occurs multiple times. Also, the word many and community, which of course is also true, because as open source developers, we are with many. One other thing that I really liked about this word cloud is, I of course didn't generate this word cloud, I found it on the internet. It's licensed using a Creative Commons license. So this word cloud was made by Nicole Baratta. I don't know this person, but let's go even further. Did Nicole Baratta really make this word cloud? What does that mean? What did this person do? Probably she found some software on the internet that generates word clouds that someone else wrote. And then how do you generate word clouds? You find a text corpus somewhere that contains a lot of words, you put it in your word cloud generator program, and then you end up with this nice picture. So how many people actually participated in building this word cloud? Maybe 100 people. A lot of them probably don't even know that they are helping me give this presentation. Probably some of them I don't even like personally. Some of them I probably don't even would trust with any personal information. So that's what this talk is going to be about. So at Tweede Golf, we work on critical infrastructure and open source projects. So one of them is the network time protocol implementation that we rewrote in Rust. And another one that I want to talk about a little bit more, because I'm involved with that, is the rewrite of the well-known sudo command that we rewrote in Rust. So who wrote sudo rs? So I'm one of the persons, and then there are 3 other core developers. So Marlon there is raising his hand. I don't actually consider Marlon a core developer at the moment, but he is one of the many contributors to sudo. So 4 people in the core team, and then there are, I haven't counted them precisely, but I think there are like 13 contributors that also shoot in pull requests in our GitHub page. And that's okay, because the core team looks at their pull requests, we review the code, so the core team knows what's going in there. So these people wrote sudo rs, except of course, that's not the entire story, because we are using Rust, and Rust has dependencies. So there are also other developers that can influence the kind of things that sudo can do with your computer. And I counted those as well, and then I count 11 developers. So they all have the ability to push commits to certain Rust crates that change what sudo does. There's even one bot. So it's a piece of automated software that can make changes to sudo. And then there are 4 GitHub teams, and of course I cannot see who is in that GitHub team. So those are 4 teams. So I just put a lot of little icons there because I don't know who these people are. Now, of course, you're going to ask me, how do I know that this is the case? That's because there's a nice tool called cargo supply chain. And if you run cargo supply chain publishers, you can get information like this. So the following individuals can publish updates for your dependencies. So Alex Crichton, one-way Rustlang owner, that's the bot, and then some other people. I asked some of my fellow colleagues, like, hey, of these 8 people, who do you know? And they said, well, we know Josh Triplett. That's the 7th one on this list. And none of the other 7. Well, that's, How many lines of code is sudo rs? Well, I counted that as well. So that's 20,000 lines of code that we wrote. We also have some dependencies, so not many. This is not a story about, oh, sudo has hundreds and hundreds of dependencies. There are only 3, actually, which everybody that writes their own Rust code probably will take their hat off for us for having managed to do this. So there's the log crate, that's 5,000 lines. Glob, 2,000 lines or so, small dependencies. And then there's libc, that's 120,000 lines. But that's kind of okay, because libc is just bindings to the C library on your system. So that's kind of okay, right? I'm not even counting, of course, the lines of code that are going into the Rust compiler, into the Linux kernel, because you have to stop somewhere. I think I will be able to make you more scared in a bit. So how do you know this? There's a command line tool called cargo vet. It does more than just list the amount of lines in your project. But anyway, the conclusions from this is, I should add here, by the way, so not all 120,000 lines in that libc crate will, of course, be actively run or executed by sudo. So that's also, I'm trying to defend sudo here. I'm not trying to tell you that sudo is crap and you shouldn't use it. You should use it because it's better. Conclusions. The core team of sudo wrote at least 13.5% of the code in sudo. So that's if I add all these lines and I calculate what's ours. It's probably more than that. But we are less than 1/3 of the developers of sudo, or people that can influence what it does. And again, I want to stress this. So we have a blog out there. We did our best to minimize the dependency of sudo. So this is a best case scenario for a Rust project. Like, people will be proud of us. So let's look at a more typical Rust project. So when I was starting to play around with dependencies, I made our own pet project to calculate some vital statistics for Rust projects. And I came up with something called cargo pulse. I'm not going to explain to you what cargo pulse does, because it doesn't matter for this presentation. But what it is, it's a very tiny Rust program. One contributor, that's me. It's 181 lines of Rust code, so that's nothing. Like, I whipped this together in 4 hours or something. It has 7 dependencies. But then if I do the same trick I did for sudo, I get 99 other people involved in my code base, 28 GitHub teams, 4.2 million lines of code that I pull in. Luckily, with Cargo Vet, I can also see that people look at that code, people audit it. So it's not 4.2 million codes that are completely untrustworthy. There's only 1.2 million codes that no one has looked at. And in total, I put in 194 indirect dependencies. So that's why I put this picture here. This is, I think, a classical picture of a world standing on the backs of elephants that stand on a tortoise. There's a whole world beneath your software project that you need to be aware of. And let's think about this using 2 ways of thinking, which is the burden problem and the trust problem. And the burden problem is simply, it's a burden if you have a dependency. Every dependency adds something that you need to manage. And the trust problem is every dependency adds some bit of trust that you need to give to someone else. And of course, trust means, if I trust you, that means you have some ability to harm me. That's what trust means. So let's look a little bit about the burden problem. So this is a dependency tree for my little pet project. So let's look at this. So these are the dependencies that I added. And I did my best here to make this fit on one slide. So this is what if I want to submit cargo pulse to Debian? I want Debian people to package it. Well, that's not too difficult. So they only have to package this dependency because that's not yet in Debian. But all the other ones are. At least they are in a compatible version. So it's not the exact version that I'm using, and it's another version, but that's probably okay. So maybe this is not the worst thing, but if you have more than 7 dependencies, chances are that it's a lot of work to get your Rust project in Debian. Now, some Rust programmers might say, I don't care about getting my software in Debian, but I think you should care, because you should care about other people using your software. And then there's one thing that's hiding behind the hood, is that in Rust it's very easy to have multiple versions of the same dependency in your project. And then if you're going to package your software, you need to handle with those as well. And so you notice here, I know the slide is a little bit hard to read maybe in the back, but for some packages there are 2 versions in Debian actually. And for one, there's only 1 version in Debian, and there's an incompatibility. And that actually, this is still for my own pet project. And when I was making this, I was wondering, so how did these Debian people actually manage to package all the dependencies that I showed you in the previous slide? And that's because they actually fudge with their cargo files before they package them. So they have to do a lot of work to get all these incompatible versions correctly. And one of the problems that causes that is that in Rust we have toml files and cargo files. Toml files and log files. Typically, we don't commit our log files, which is a pity, because they contain the versions that at least one developer managed to get a working build with. And the toml files, typically, you add a dependency. That's the point where it gets added to your toml file, and then you don't bother updating that as your project goes along. So the information in your toml file might not be accurate a year from now. Then there's another way to look at this. Suppose you don't care about packaging for Debian, but maybe you care about shipping it to your customer. So this is all the licenses for all the dependencies in my pet project. Can I ship my pet project under the Apache 2 or MIT license? We can hold a long discussion based on this list. Most developers don't like reading open source licenses. The one thing that I can see, I see a lot of Apache here, so that's probably fine. I do see here a custom license file, which worries me a little bit. I also happen to know that's Ring, and a lot of Rust developers, they have to work around that a bit, because Ring has a complicated license. And then there's the MPL2, which is a copyleft license. And we should respect our copyleft licenses. Yeah. I'm not going to answer if I can do this, because that would be legal advice, and I don't want to give legal advice. So let's look a little bit about the trust problem. So Rust is memory safe. That's why we write Rust, right? That's cool. Of course, there's also something called unsafe Rust, and then it's no longer the compiler that guarantees that there's nothing called undefined behavior, but the programmer. You have to trust the programmer to do that. So my pet project, which is 180 lines of safe Rust code, so I didn't use any unsafe Rust, I can run a tool called Gargo Geiger on it and see how many times is unsafe code used in the dependency tree. And that turns out to be 20,000 unsafe expressions. One of them is enough to completely destroy the safety guarantees of the Rust compiler. Of course, this is still better than the C project. In the C project, every line is unsafe and untrusted, but it's still more than you'd expect, probably. And then, of course, if you make bugs in your code, that leads to vulnerabilities. So this, again, is for my pet project. I do admit that I did some cheating here with the versions that are in my log file to get nice vulnerabilities in my project. But my pet project actually has 2 vulnerabilities in it. Including in a create simple ASN1, I don't even know what it's for. I didn't know it was there. The good news here is, of course, we know how to solve this problem. There are tools here for this, Cargo Audit, where we have the Rust Security Advisory Database. So in principle, this is a problem we know how to manage vulnerabilities. Like, we don't like them, but they do occur. But then, of course, my question is, do all developers report their vulnerabilities? Because when I checked RustSec, like for some crates where I'm pretty sure that they probably had some CVEs in the past, or they should have had, I couldn't find them in the RUSAC database. So maybe there are also some very young developers that made an embarrassing mistake, and they like just yank the version from crates.io, push an update, and they go, whew, nice, dodge the bullet there. Or maybe they're not even actively maintaining their packages anymore. So there's a bug there, there's a vulnerability, and it's not being fixed. And there's my favorite one that typically people don't think a lot about. So suppose I build my Cargo Pulse pet project, and all of a sudden I get sudo asking me for a password. What's going on there? Luckily, I got a password. Like if I had used sudo in this terminal 5 minutes ago, I wouldn't have gotten that password. And that's of course because every time you compile a dependency, it has a build.rs file, which gets compiled and executed, and it's getting run. And it's getting run in your own terminal. It's not in any kind of sandbox. Yeah, good luck with that. So far, I actually got this idea from a talk that I watched in Rust Nation a year ago in London by a company called JFrog, where they assured me that in the Rust ecosystem right now, this is not yet a problem. But in the Python and NPM package repositories, there are examples of malicious packages where people are trying to hack computers of developers to get malware installed on end users' computers. So this is something you need to worry about as well with every dependency. And then, again, think about that slide with all the little people on there. Who are these people? So my colleagues knew Josh Triplett. That's cool. I think I've never met Josh Triplett personally, but I know who he is. I also know someone called Dave Tolnay, but he wasn't in that list. But then who's John Titor? Has anybody here met John Titor? So I actually Googled his name, and I did remember this. So in 2000, there was this person on Slashdot that claimed to be a time traveler from the year 2033 that went by the name John Titor. So this is just an alias. Or maybe there's a time traveler that's writing Rust software. And then who is GNZ? I don't know as well. Okay, I use a nickname as well, so that's fine. But then how do we know that if we accept that Josh Triplett is this person that we trust, how do we know that we are actually getting our software from their computer? Which means, how well do they protect their password? How well do you protect all of your passwords? And if they do, so suppose they make a bug, do they respond quickly to bug reports, or do they say, well, this is not really an issue, or you're using it wrong? And then, of course, and maybe the graphic here is a little bit of a hint. If it's one person that's maintaining an important crate, can some malicious actor do something about that? Like, can they be coerced in doing something? So this image from XZ, I put it on the slide. It's the one image that I don't really care about attribution, because this is supposedly made by Jia Tan. I apologize for my pronunciation of this name, but I'm pretty sure this is not a Chinese person. And well, you know the story about the XZ Utils hack, kind of. So there's a technical, interesting side to that I don't really care about, but there's also the social engineering side to this. So there's one lone developer, and he gets pushed and bullied into making some changes to his code base, or actually his build scripts, and that turns out into this entire big hack where we really dodged the bullet there as an open source community. And then we get to the trust issue. So how do we know who these people are? Well, we have cryptography. And for that reason, I really like the talk that was in this room this morning about key oxide, which tries to address this problem, because right now the public key solutions that we have is, well, we have SSL certificates, but we use them for websites. We don't. You can apply for one for your email, but almost no one does that. Then we have, of course, signed commits on GitHub, That means that I upload my SSH key to GitHub, and then GitHub puts a little green check mark next to my commit, but how do you know it was me that uploaded the SSH key in the first place? And then, of course, there's OpenPGP. Now, I happen to like PGP, but that's because I'm a huge nerd, and I already was a huge nerd in the 1990s. It's archaic. I also noticed all of my colleagues hate it, and they don't know how it works. And of course, in 2019, the key server network was compromised. So the web of trust no longer really functions as it was intended to be. So with PGP keys, you're still in the same position as a signed commit, where you don't know how you got this PGP key. So luckily, there are some like projects that try to address it. So one of them that's not on the slide is apparently the key oxide project that you talked about. And the other one is that there's a new project that recently went public that's called the Trust over IP Foundation. They're working on something called the Trust Spanning Protocol that also tries to address this issue. And I think it would be really good if people that care about this took a look at that. Because I think during the Q&A this morning, there was also this interaction where someone said that there are people that really like cryptography and there are people that like this identity thing, and the two don't really mix. And I think that should happen more. I think more eyeballs should be busy looking at this problem. So this is all a doom and gloom story so far. At least that's the intent. So let's get to a more hopefully happy note. So what can we do about this, and what shouldn't we do about this? Well, there's not really a great answer here. This is not an easy problem, right? Here you do this, and then you fix this. That's because modern software is incredibly large, and that's also because we place great demands on it. We want to have a nice, shiny user interface. We want to be able to run it in our browser. So for that, you just need to have a lot of functionality, and you're not going to implement all that functionality yourself. So you're always standing on the shoulders of giants, or at least you're standing on someone else's shoulders. And those people are standing on other people's shoulders. And that's not something to be only pessimistic and negative about, as I've been so far. So let's contrast two approaches here. If you say we don't like having many dependencies, then what you're saying is I want to have a big dependency, because I do need all that functionality. So is that better? And my answer would be no, that's not better, because then every time you want to have this one little feature, you bolt on this big dependency to your project. And I don't think that's a great idea, because then you also pull in a lot of code that way. And of course, if many people depend on one dependency, then once they make a design choice, and then 2 years later they discover, well, this was not a great design choice, we need to change this. Then they find that they can't, because so many people are depending on that dependency. This, I think, has happened to the Ghost standard library in a couple of places. So having small dependencies is actually also a good thing. Even though you get a large, what's called a software bill of materials, it also allows you to make these slides that I just made, where you get all these statistics. So you can analyze and you can manage them somehow. Also, I want to stress this, if you're reading or following this talk, I'm not bashing Rust here. This problem exists in every programming language. It just happens that Rust makes it more easily approachable. And also Rust has a lot of other benefits, such as its good type safety and other benefits. So that's why you should continue working on Rust, but also try to solve this problem. And of course, the other thing is open source is not the issue here as well, because large corporate software also has this big code base, except that they put a nice black shiny wrapper around it, so you don't see it. Okay, maybe a company will sign a contract with you saying that, well, we take the blame if something goes wrong, but what if the company goes bust or gets taken over by some other company? So one other bad solution that you should not do, but probably a lot of people are doing this, is instead of taking a dependency, you just copy a little bit of code, the code you actually need. So I know a lot of people have done this, and we have done this, but there are, of course, big downsides to this, because what if the original author discovers a bug or vulnerability in the code you copied? Then you don't get this update, and you also don't get it in your cargo audit or your cargo Geiger or your cargo vet. And also, so this licensing stuff, and I know not many people worry about this licensing stuff, but you should respect licenses. You're probably not copying along the licensing information as well. So this is a very bad solution. This is an anti-solution. Don't do this. What you can do, so there are some easy things. This is not a complete fix. Like the best thing for you to do is be aware of this problem. But what you can do, so every time you take a dependency, think, do I need this dependency? And check its source. So if it's on Creatio and it has like 12 downloads and it was last updated 4 years ago, maybe it's a bad dependency. Maybe you should find another one that's more popular. So one thing that I heard in discussions this morning with multiple people is you use feature flags. So if you're publishing a crate and you pull in a lot of dependencies, don't force all of those dependencies on your end users. Give them a fighting chance to reduce that burden by hiding some behind feature flags. Maybe not every user of your crate wants the full shebang. They just want this one tiny bit. You could also, of course, split up your dependency in tinier dependencies. Ooh, am I advocating for more dependencies here? Participate in RustSec. I don't think everybody is doing that to the maximum. What we could also do, of course, as a community, we know what popular dependencies are. Like something like Tokyo is probably part of the standard Rust library, even though it's not officially a standard Rust thing. So there's an initiative here called blessed.rs, whereas like I think 5 people made a website where they listed some crates that are very popular and in their eyes are well maintained and good choices to take as dependencies. And then one other thing you could do is look at what Linux distributions do, because they have been managing dependencies for their operating system for the past, well, how old is Debian? 1995? That's over a quarter of a century of experience. So they use signatures on every package. They nowadays make sure that they have reproducible builds. So even if one machine is compromised, unless all machines are compromised, you're still getting like a nice, reliable build. And they have all kinds of hygiene checks. So if I want to make a Debian package, typically you run a tool called Lintian on it, and it will nag and complain. It's like a cargo clippy for your package. And that also, I think, increases the quality, which is why Debian is such a nice operating system, which in turn means that's why Ubuntu is such a nice operating system. If you want to read more, I recommend going to our blog. So there are 2 links here. I'm pretty sure the slides for these talks will be published afterwards. At least I hope they will, and otherwise you can find them on our website. But let's close on this thought. So security is a trade-off. So we know things can fall from the sky and it can hit our homes, and we worry about that, hopefully to a very small degree, because most of those times it won't hit our house. But maybe we should worry about it a little bit more. And this depends on your project. So for sudo, we want to have a small attack surface, and a lot of things can go wrong. And if things go wrong, people won't trust our sudo implementation. If I'm writing my little pet project that I just hack together in 4 hours, and I just like want to play around with it, and I'm not going to distribute it, then you won't worry as much. So you always have to balance how critically you want to take this with the risks you're willing to accept. And then I want to leave you with this little image. So what I like about this image is that I cannot tell if these people are taking apart this QR code or they are trying to put it back together again. And are they taking it apart or putting it back together because they are trying to help build the QR code, or are they trying to destroy the QR code? And I think you can interpret it multiple ways. So the fact that there are multiple people behind like our Rust software, it's on one hand a good thing. It means we are a healthy ecosystem and lots of people are collaborating towards a brighter, more safer future. But there are also some inherent risks. And I'm not telling you to not sleep tonight over this, but next time you distribute a Rust package, like, have a look at your dependencies. Thank you.
This is a very good one. Any questions on this is software supply chain security challenge? And you also got tools to help people to vet what kind of the sources of the software that you are incorporating in your software development process. If there got one question over there.
Would you say it's fair to liken this problem to insurance from the idea of, I mean, I've worked in a company with about 100 developers before, and the pressure is to deliver quickly rather than securely, right? And it's effectively a trade-off in the respect of how fast can you go without breaking everything. And this is kind of an insurance trade-off, I guess. Would that be fair to say, or?
So it's a little bit hard to hear your question from the back because you're being broadcast from that speaker. But what I get from, so I heard you say something about during a software project you also sometimes want to go fast and break things. And how does this balance with this idea of making sure you get higher assurance?
Yeah.
Yeah. So there's a link to our blog here. So a colleague of mine wrote a blog article about how we did this during the sudo development project. So in the first 2 months, we didn't care about this. We needed like a password prompt, so we took a crate that gives us a password prompt. We needed to talk to PAM in Linux, so that's for authentication. We took a dependency on PAM. And then we started looking into this dependency for PAM, for instance. And I think we even met one of the maintainers on GOSIM this morning. And he also said, like, no, it's not well maintained at the moment. And we also came to that conclusion. And so then we started re-implementing that ourselves. And then we could shred that one. And then I think in May we were down to 13 dependencies. And then we started looking, like, do we need this functionality? So at some point we had digests. We had hash functions in sudo to calculate SHA-2 digests. And that was used for one really obscure sudo feature. And then we made a decision that probably people are not going, like, nowadays probably people don't use this sudo feature, so we're going to remove this. And then if that breaks a lot of people's code, they can come back and then maybe we can add it later, but let's be bold and let's remove that. So we still got the initial ramp-up phase where we could quickly hit the ground running. And that was also the phase where we had a big warning sticker on our GitHub page saying, don't use this in production code. So that would be my answer, I think.
Yeah, so, okay, okay. Thank you so much, Marc.